So through any 2 points, there's exactly one line. They talk about a lot in geometry about what an intersection is. And an intersection is the set of points that 2 or more figures will have in common. So if you think about roads, right? When you're driving down the street, there's a road going, let's see, Dumont, right? This is Dumont that we're on. Dumont's going this way, and then Artesia goes this way, and they meet up. And it's like, is that Dumont where they cross, or is that Artesia where they cross? Because they cross over. That's an intersection. They have something in common. So that middle area where you cross through is in common. That's their intersection. So what we're going to do is talk about the intersection of some different things. Points, lines, planes. How do they intersect? Okay. So postulate 1-2 says if 2 distinct lines, so 2 separate lines, intersect, they're going to intersect in exactly blank point or points. What do you think that is? If I take a line and then another line, how many points do they meet at? 1, right? The only point they have in common is this point right here. So they intersect in exactly 1 point. Okay, so that's postulate 1-2. So we could say, if we wanted to name that, this is A, B, C, D, and E. We would say line AB and line CD. Remember, you write lines with the arrows going both ways over top. Intersect at point E. Okay, so E is their overlap, their intersection. Questions on that so far? Okay, so then it's postulate 1-3. And now we're talking about planes. So for postulate 1-3, it says if 2 distinct planes intersect. Remind me, what is a plane? What did I use yesterday to represent a plane for you? Do you remember? What? When we drew it, it was a parallelogram. Yep. What did I use physically? What did I show you with? Do you remember? A piece of paper, right? So a plane, think of it like something that has no thickness, keeps going forever, right? That's a plane. This says if 2 distinct planes, so if a plane here and then a plane that goes through here intersect, they intersect in exactly 1 blank. So I want you to think about this, okay? Think in terms of the floor being 1 plane, okay? So my carpet is a plane that comes over to here, and then this wall is a plane that comes here. Yeah?
One side.
One side. You're on the right track. Where are they meeting? Where is the floor meeting the wall? At the bottom of the wall, in that corner, right? And if we think about what that corner represents in terms of what we talked about yesterday, it's like this, okay? But it never ends, because planes never end. What is the thing that goes like this that never ends? A line. Right, so if you have 2 planes that intersect, their intersection always has to be a line. So in exactly 1 line. And if you want to just make a note in your notes, on page 30 in your book, or you can open your book to page 30 if you would like. But on page 30 in your book, there's a picture there. It looks, I'll sketch it for you, but I don't do it justice. You'll have a plane that goes like this. Let's see. Okay, so it's two planes that are overlapping here. But in your book, it's awesome because you can take that picture and you can manipulate it. So you can rotate it, you can turn it, you can see where they're intersecting. But if you look where this blue and red plane meet, it's right here. And because planes keep going, the intersection would keep going. So their intersection is that line. Okay? Questions on that? Okay.
Freshman with.
Let's say there was a point here and a point here. So this is A and this is B. If that A and B are on both of those planes, which right now it's on the blue plane and it's on the red plane, then the line would be line AB that they have in common. Okay, so if they share points, then their line is named by those 2 points that they shared. Okay? Okay. So this is example 1 that we're doing today, but it's example 3 in your book. So because we're doing the second half of 1-2, here's your example 3. I want to know the intersection of plane ADC and plane BFG. Okay, so first of all, before you even try and figure out what the answer is, can you tell me 2 planes always intersect in a what? What is their intersection going to be? Don't give me specific, just a point, a line, or a plane. If 2 planes meet, they meet in a line. Okay, so we're looking for a line here. So we got to figure out what line is the intersection of these 2 planes. And if you look at, are you going to give me an answer? Yeah. Okay, hold on one sec. So you have plane ADC and you have plane BFG, okay? Don't let it throw you off that there's only 3 letters when the figure that you're looking at is going to have 4 letters in actuality. So plane ADC is which side of this box? Top, bottom, left, right, front, back. It's the top, right? ADC is this one. Okay, so they're asking where does that plane intersect? What's BFG? That would be the right side of the plane. So that would be this one. Right? So the question is, what is their intersection? Cameron.
Line BC.
It's line BC. Right, so you're looking for where did blue meet up with green? Right? Where did they meet up? That is your intersection. So this line right here, line BC, is where they intersect. Okay. So that's part A. And then I'm going to erase this so we can do the next part. Okay. Part B, it says name 2 planes that intersect at EF. So you have to figure out where is EF. Line EF is that bottom front line. Okay, so you're looking for what 2 planes meet there. Could you tell me what 2 planes meet there? Can you tell me in terms of top, bottom, left, right, front, back? How about first? Yeah, Cameron. The front is correct. It's not the right side. The bottom, right? You're looking for the front and the bottom. Oops.
I forgot there was a bottom.
That's not cute. Let's try that again. So the front and the bottom. Did the internet just kick out? Why did that stop recording? So front and bottom is what we're trying to name. Okay, so can someone name that front plane for me? So this plane here, how many letters do you need to name a plane? 3. Okay, what points make this square? A, B, F, and E. Okay, so you can pick any 3 of those 4, or you could just pick all 4 if that's more helpful for you. Okay, so we would say the front plane is plane ABFE, or you could just say ABF or ABE, okay? How would you name the bottom plane? Can't really see my letter there. Can you see that? So the bottom one would be what?
EFGH.
Yep, so HEFG, EFGH. And one thing about naming planes is you go in order. So you don't want to do HFGE. You want to do HEFG or EFGH or GHEF, but go in an order. And you can go clockwise or counterclockwise, but just follow the flow. Okay? So plane ABFE and plane HEFG. Okay. Questions on that? Okay. Last postulate then, I think is on our next page. Yes. Am I good to move from here?
Yeah.
Okay. All right, so this is my favorite one. I don't know why. I just like it. Postulate 1-4 says through any blank non-collinear points, there's exactly one plane. Okay? What do you know what non-collinear means? Not on the same line, right? Because collinear means they're on the same line. So non-collinear, they're not on the same line. So how many non-collinear points do you think you need to get exactly one plane? 1, 2, 3, 4. You think 4, Cameron? How about, so if I drew a plane and I put 1, 2, 3, and then 4, is there a plane that goes through all 4 of those? There's not, right? So it's not 4.
So it's 3.
Right. Could it be 2? Is there, if I were to draw 2 points, 1, 2, is there one plane that goes through those 2 points? Let's say I put 2 points on me, a point at my fingertip, a point at my elbow. Is there one plane that goes through those? Here, 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 right? There's a whole bunch of planes that could cut through that. So it is 3, through any 3 points that are not in a straight line. Okay, so through any 3 points that are not in a straight line, there's exactly one plane. Here's why I love this one so much, I think. Are any of you into photography? Yeah? Okay. Okay, so if you're doing photography and you want a still shot, you want just like a nice shot, no movement, but you're waiting around for this spectacular animal to walk by or something, what do you put the camera on? Do you know? What kind of stand? A tripod. A tripod. Because through any 3 points, there is only one plane, right? Have you ever sat on a stool that has 4 legs? And it wobbles sometimes, right? Like, mine's pretty good right now, but it wobbles a little bit. If you have a stool with 3 legs, it won't wobble, okay? It might be, now here's the catch. If I had a stool with 3 legs, so take a leg off, and I made one leg like this, it's not gonna sit up straight, right? It's gonna lean, like, severely. So it might not work as a stool, but those three points will always rest flat. For instance, if you take your 3 fingers, they're different lengths, right? But if you keep them straight, you will always be able to touch those points. Now, if I took a 4th finger, I can't necessarily get that finger with my fingers straight to rest, right? So through any 3 points, there's always going to be one plane. It's like a tripod or a stool that has 3 legs. It's a beautiful thing. Any questions on that? Okay, so last example then. We're going to take this picture here, and it says, what plane contains those 3 points? And we're going to draw the plane in. Okay, so you're going to be shading in planes. And I will shade them all differently in different colors, but I'm going to erase in between each one. You guys probably won't be erasing between each one. Yes, sir?
Okay, so I have a question.
Yeah.
So you said they're so I have it's not really a question, it's kind of like
A thought.
prediction. So could a plane, would one of the planes be like NMLP or NML?
NML. You could put a plane through N, M, and L. Now, here's the thing, right? So if you think of that picture kind of like a Kleenex box, okay?
Yeah.
If we're thinking N, M, L, I gotta think from your perspective. So N is here,
Okay.
right? M is back here, L is back here. The plane that would cut through those 3
It would be like a triangle.
goes like this. It's kind of slicing this whole thing diagonally, right? But you can put a plane through those 3. Now, if you said N, M, L, Q, that's 4 non-collinear points. You can't put a plane through those 4.
L and Q are on the same line, though. Are they not?
They are, but we're trying to get M with it. M, L, and Q would be the back plane, right? If we try and lump this N in with it, you can't have this with this, right? It's a good question. But yeah, through any 3, you'll be able to make a plane.
Okay.
If it's 4, not necessarily, but sometimes 4 does work. Oftentimes 4 does work. Okay, so let's look at this. What plane has points N, P, and Q? So if you look at N is here, P is here, and Q is here. What face of our box is that? Top, bottom, left, right, front, back. What? It's the bottom, right? So the plane that includes those, for me, is the blue. It's the bottom.
It doesn't matter if there's no like R.
Right. They could have said R with it because it does include R, but you only technically need 3 points to make a plane. So they just give us 3 to start with. Yeah.
So it's not like we're not trying to like make a plane. We're just finding the ones that they're.
You're going to shade the plane that they're talking about. Yeah. Okay. Okay, so now let's look at this second one. It says, what plane contains J, M, and Q? So here's J, here's M, and Q is down here, right? So this one isn't like a front, back, top, bottom, left, right. This one cuts through the figure. Can you tell me what the 4th point in this picture that would be included would be? Would be what? P, right? Because these 2, and then with these 2, would match up. So if we just connect those points, connect J to P, connect M to Q, and shade that in, it's like a ramp, yeah. That would be the plane that's in there. No, you wouldn't call it. I mean, it's a rectangle, but it looks kind of like a ramp going up, right? You would just shade. You're gonna take that figure and you're gonna shade it in.
Oh, okay.
Yeah. So your answer is the red that you see here. So for me, it's the red, which is it's like a diagonal. But this is just me telling you this is your answer. You'll actually shade it in. Okay? Yeah.
Are we gonna have to know shape names?
Yeah, eventually we'll talk a lot. We'll name shapes a lot in here, so you'll get used to it. Okay, last one. Which plane has M, L, and Q? the back, right? You have M here, you have L here, and you have Q here. So if we were to add a fourth point, that would be point R. So that plane, this is getting real hairy now, is the back face, which is the green in our picture. Okay? Any questions on that? And if you want, like, on a problem like this where there's so much shading, color coding is really helpful because then you don't feel like you have to redo the box every time. You can just use 3 different colors. So if you want to do that, feel
All
free to do that.
freshmen who have not had their